In this series of figures, we're going to look at liver and pancreas secretions, how they occur into the duodenum, and what they promote. Now, at the upper left here, we have sort of a miniature version of the associated anatomy here. And so we've got our esophagus, right? So food would enter from the mouth, lead into the esophagus, and then be processed in the stomach for a prolonged period of over several hours. Now, the key actions aiding digestion in the stomach are the secretion of acid, so free protons here aiding digestion, but as well we secrete a protease known as pepsin, and that's going to aid in the breakdown of proteins into small peptides and individual amino acids that are then going to be later absorbed. Now, we're not completely done with digestion in the stomach. We're going to have to pass through a pyloric sphincter here at the junction between the stomach and the first section of the small intestine. That's known as the duodenum. And then in the duodenum, you can see we have this confluence of ducts. We have the common bile duct coming down from the liver and the gallbladder here. We also have the pancreatic duct. And so what we're going to see is the secretions of those two structures, the liver and then stored in the gallbladder, bile will be released through this duct, as well as pancreatic secretions released similarly at this location into the duodenum. So we're going to blow that up down here and look at before a meal, what this all looks like before a meal. Right? So before a meal, the liver, which we've removed here for clarity, is producing bile, and that bile is entering a duct-like system and being stored in the gallbladder. The gallbladder is simply a muscular bag. It does help concentrate the bile a little bit, but that's about all it does. It sits there and holds it as it's being produced by the liver, waiting for that next meal to occur. Now, it's being stored because that is the low resistance pathway here. The common bile duct that would lead to the duodenum is closed off by this sphincter of Oddi that's constricted between meals. Similarly, this sphincter of Oddi impedes the flow from the pancreatic duct. So even though we're not stimulating the pancreas yet, even if any secretions that were being produced would not actually enter the duodenum yet. We don't want to release enzymes here if there's not food here. And so this is all sort of inactive at the moment until we start to process a meal. So now we're going to transition to the right here. And on the right side, we're going to have a whole variety of stimulatory actions and responses that occur. Now remember, the stomach is doing its thing first, and so we're sort of jumping past that. So that up here in the stomach, we've got our chyme, this blob of chyme that's being processed with, again, the acids and the pepsin and the mixing that's going on there. And we're very slowly going to release it across the pyloric sphincter into the smaller volume duodenum. So here's that chyme now entering that duodenum. And one of its characteristics, of course, is that it's very acidic. And that's going to immediately stimulate the production and release of the hormone secretin. And secretin is known as nature's antacid because it so strongly stimulates these pancreatic ductal cells, found right here, to produce and release bicarbonate. And that bicarbonate right here is a buffer for those free protons, bringing our pH up from a low of about 2 up to as high as about 6. And that's absolutely essential, as the enzymes that we're going to be having released here as well do not work at a pH of 2. They have a much higher pH optimum. And so we need to buffer that chyme through the release of this bicarbonate ion. Now, that chyme is also going to contain fats in many cases that are going to be stimulatory to the CCK secreting cells. CCK has a whole myriad of effects, one of which is to open up, relax this sphincter of Oddi. This is actually going to allow that bicarbonate to enter, but that CCK is also stimulatory to the acini, these acinar cells that are the enzyme-producing cells. And so we're going to get a whole variety of enzymes now for every nutrient type, essentially. Carbohydrases for carbohydrates, proteases for proteins, lipases for lipids, even nucleases for nucleic acids like DNA and RNA. And so we're going to release that whole myriad of enzymes and have dramatic digestion of all nutrient types in the duodenum here. Now, that CCK, in addition to acting here on the enzyme secreting cells, is also acting over here to constrict the gallbladder. This is going to drive that stored bile through this common bile duct into the duodenum as well. And here we have it. And that bile works to emulsify the fat droplets that were stimulatory to the CCK in the first place. And emulsification is sort of a stabilization of small droplets. We can see them here, each surrounded by those bile salts. And that's important because it dramatically increases the surface area for those lipase enzymes to act on the fats that are within these little fat droplets, aiding digestion overall. Now, we also get secretion of another hormone down here, GIP. This is glucose-dependent insulinotropic peptide. This is a hormone that stimulates insulin release. If you think about it, a carbohydrate-containing meal is going to immediately increase blood sugar levels, blood nutrient levels in general, and insulin acts to help with the storage of those nutrients following a meal. Now, we're processing all of this food, we're deacidifying the chyme, and so later on here, as we enter the latter portions of the small intestine, absorption of those nutrients is going to become a key function.